Thank you for the introduction. Again, I'm Ana Carcedo, and I'm the Broadleaf Agronomist, and I'm going to be talking about the variety trials and how to use them. So for all the getting it right, I choose this topic. I think it's really important. So if you had connected in some of the previous getting it right, you are going to see some slides that I keep using. It's concepts that I think they're really important, and I really want to talk about that. So, well, Barry already showed it, but this is our production guide, and I'm going to just highlight all the important information and highlight that if you have any questions, please go dig into this guide. It has a lot of valuable information, and if not, just also please send me a message, and I will love to have a conversation with you. Saying that, let's start with the reality. This is something that all the presenters have been talking about before me, so it's not new. It's the production and the acreage have been diminishing, and saying that, I also think it's kind of a shame. Some of the most beautiful things that we have here in North Dakota is that all the diversity that we have in the crops. It's not only soybeans and corn, and saying that it's some of the things that it's incredible. And when we are talking about flax, it's really nice how it fits in a rotation, how it goes really well. It goes really well with small cereals. Also, I've been hearing more and more about using flax even as a cover crop, but also intercropping flax with other crops, and how flexible it can be. So there is a lot of room for improvement here. One of the things that it might be leading also this decrease is the high variability that we are having in yields, that we have good years, bad years, and the yields that we get, depending on the weather and the conditions of the year, it changes so dramatically. So it's a huge thing. Saying that, probably you already noticed, but it has been told before, we have different kinds of flags. When we're talking about the color, we have the gold or like the yellow one and the brown one. And the main difference when we are talking about this from a agronomy standpoint, I will say it's like the yellow one have like a thinner tegument, so it might be more vulnerable than the brown one. But so it's just things that you have to consider. And then we're going to start talking about what it actually concerns about today and what I want to show you today. That is the variety trials. So if you are interested on seeing this, we have printed copies. We send it to most of the counties here in North Dakota. So if you want to have it, your county already gave them all, just send a message and I will be happy to deliver it for you. So and if you don't want a hard copy, it's also available on internet. So get your Flax variety trial copy. Saying that, I have to say this has such an amazing and such valuable information. And I'm going to be talking a little bit about that. So something that is incredible about doing research from a university and all the value that this has is that the data is reliable. So I don't have to tell you that if you're working for a university, your information isn't biased. You're not selling any product, and your real objective always is the best for the farmers. Then another thing is that at least here in North Dakota, we are really thankful and really grateful for all the sites that we get. So the university has at least 8 sites across the whole state where it has research for extension, and that's so valuable. And we should be really grateful that it doesn't happen in every state. And then we also have a specialist. We have people that really know what they are doing, and when they're sitting down and talking about experimental design or which statistics they have to do on how to deal with a crop, they actually know what they're talking about. So it's all these three components. And as I'm talking about experimental design, I'm going to be talking about two concepts that I want you to understand. And I want you to understand this because it's actually beyond variety trials. It's how you understand any research, any experiment that anybody is showing to you. I'm not saying that a company will do the things wrong, but I'm just saying that if you have this knowledge, you can check how robust the information that is being provided to you it is. So saying that, I'm going to be starting with these two concepts that I want to explain to you. First, replicate it. So when we have a trial, when we have experiment, we don't have the things only once. We repeat it at least 4 times when we are talking about the variety trials here in North Dakota. So imagine that each one of these balls of different colors is one different variety. We will have it 4 times at least. Depending on what you are measuring, and if we are talking about experiments in general, we are going to see that it depends on how hard it is to measure, how many repetitions we need. So if we are testing a product that it goes in the soil, probably I will request, I don't know, 7 to 8 repetitions, because it's harder to measure. But when we're talking about yield, usually we say 4 repetitions. It's something that it's okay. But it actually doesn't stop there. We have to replicate or treatments or varieties in this case, but also we need to randomize. And why is that? It's because I know you are familiar, even in your field, it's not completely homogeneous. It's not the same in each part of your field. It's something that you're familiar with. And you know that, for example, in this diagram I included there is probably a section that has higher yields and a section that it has lower yields, and we know it. So when we are doing an experiment, we don't want to see those differences. We actually want to see the difference between the treatments or the varieties that we are testing. So in order to try to deal with this variability, that's not the one that we want to identify, what we do is we randomize or repetitions. So we put it in a random way in the field. So saying that, it's the way that the statisticians find out that we can actually discriminate between what was the treatment and what was just the field variability. So next time someone is showing you something, I want you to ask, okay, how many repetitions did you do that? Did you randomize? Or did you put them all in order? Sometimes this is really frequent when you're going to a demonstration, that just for them to look pretty, you're going to see them the treatment side by side in a gradual disposition, and that actually is not scientifically correct. So don't trust those demonstrations as actual values. Saying that, I can talk about this so much, and last time I talked too much, so I'm trying to go fast with this. So here is just an example. It's just one of the tables that we got from this year variety trial. I'm going to be pointing out some things that you should see when you are checking these tables. One of the things is here. We identify which site are we representing. So when you are checking this data, you should check if particularly the data from the sites that they are close to your field. So that will give you more valuable information closer to your reality. Saying that, also I'm going to point out this part here in the bottom part of the table. We also provide all the agronomical data that it's linked to this table. So planting date, harvest date, which was the previous crop. Depending on the table, you might have more or less information regarding that. If you have any other questions, for example, like any other detail that you want to know about the agronomic management that was carried out, it's okay. You just have to send an email and I will be more than happy to talk with you, or just give me a call and I will be more than happy to talk to you about how this was done. Saying that, let's go to the table. So we have a lot of information here, right? We have like days to flower, plant height, oil content, and also for sure we have our start yield. That's something that we really care about. But let's go a little bit slow here, right? So let's see days to flower first. Here what I did is pull together the data from across all the sites that are reported in the variety trial. So this is how variable was flowering, days to flowering in all the sites. So when we see here, we can see that most of the varieties that we test here at NDSU, they might be variable across sites. You can see that on the size of the box. But actually, they don't vary that much. They might be going from 55 to around 50. There's only one variety that was clearly shorter in all the sites, and this was CDC Dorado. Saying that, let's keep going with another trait. Now, let's see height, for example. Again, there were some kind of differences in height when we're seeing this data. But again, the one that was clearly different and clearly shorter, it was CDC Dorado again. So just to keep in mind this how these varieties are different. So we were talking about yield, right? And this is something that is really important for us. When we are talking about yields, something that we should highlight is this line here that is LSD 10%. So what is this? This is the least significant difference, and 10, it means that this was calculated with a 10%. So when we cross this row and this column, we see this phi. And what it actually means is that for two of these varieties to be actually different, what it has to happen is that they have to be at least 5 bushels per acre difference. So if we see the first line, we see that AAC Bright is performed like with 21 bushels per acre. And the second row, it's AAC Marvelous, and it performed with like around 30 bushels per acre. I'm just rounding up. So when we see this difference, we say, okay, this difference is higher than 5 bushels per acre. So these two are significantly different. So statistically, from a statistical standpoint, they are different. If we compare Marvelous with Carter, we can see that the Marvelous seem to be higher because it's closer to 30 and Carter is closer to 28, but they don't have this 5 bushels difference. So they are not statistically different. So just for you to consider that. And then why is that? I'm going to give you an example that I use in soybeans to try to explain why we should care about this. It's basically because if we just compare average differences, this can be really misleading. So we have this example here with two fake varieties, variety X and variety Z. And we can see here that variety X had 54 bushels per acre and variety Z had 59. So if you see just that, you will say, okay, but it seems that variety Z, it's better. It has higher yield. But when we see the p-value here that was reported, we see that it says that it was 0.52. And this is basically saying that the probability that they are different is actually the probability that they are different is only 48%. So it's just the opposite. This is the probability that they are the same. So basically, when we're talking about p-value, we want that this should be significant at 10 or 5%. And that's the 10% that we were talking before. So we are seeing that this is, okay, even though we see this trend, they are not statistically different. And now let's see a little bit of the raw data to try to find out what is happening behind the scenes and why this is not actually showing. So we were talking about repetition. So in this experiment, we have the first repetition and the variety X and the variety Z. Actually, they are not that different. If we go to the second one, again, they are not that different, and variety Z is actually a little bit higher. But then when we go to the third repetition, we see that the variety Z had much more yield than the other one. And basically what we are seeing here is that probably these differences that we are seeing in the average, it was only led by this only repetition. And then the 4 repetitions that are, again, kind of the same. So when we are talking with an agronomist that is taking care of this data, they might just remove this repetition, and there is a lot of way to deal with this information that they are called outliers. That is, this data that is extremely different to their general trend. So then what we are seeing is that in most of the repetitions, the behavior was really similar, and only one repetition is leading to this difference. And this might have been an error in the measurement, error in the recording of the data. It could have been something influencing that treatment that is actually not real. It's not the real difference between the varieties. So saying that, please consider a small but significant yield advantage. It's much more meaningful than a larger but non-significant yield advantage. So take that into account when you are checking the data. So going back to our table, right? What we are seeing here again is that we have another statistics that we are always reporting, and this is the CV. And where we are talking about the CV, it's a coefficient of variation, and it's trying to report how close an individual observation is close to the experimental mean. So this is a big definition, and it actually for me is not really friendly. I'm really more a kind of person that understands better the things with images. So I brought you that. So when we have a low CV, we are saying that we are closer to the average, so we are scoring really close to the target. And then when a high CV, we are all over the place. If we want to see this in a more data-oriented example, we might see, for example, a low CV will behave like this. All the observations are close to the mean, this yellow dotted line. But if we go to the other one, basically we have the same mean, it's the same value, I think it's 33. But each individual observation, it's really different from this mean value. Saying that, just for you to understand, when you're seeing that, you're actually seeing kind of the variability within an experiment. Saying that, I'm trying to rush across all my slides. There is 2 concepts that when we're talking about yield, they're really important. One is yield potential, and that's kind of where we're trying to describe when we're trying to see those significant differences. We want to see which one scored the highest, and it was there always in the top. And then there's another concept that for me is really important, more if we are talking to farmers, that is the stability. That is that capability of some varieties of perform constantly, to be always around the same value, and it won't be the highest sometimes in the best years, but it won't drop in the worst years. So let's see a little bit about that with our variety trial. So saying this, these are again all the varieties that we tested, And the different color points are the different sites that we included in our variety trial. So we can see that there are these 2 points here that probably there is something going on. So for this presentation, I'm just going to ignore them. But we can see that there is some sites that they're always on the top. They're always performing better than the other ones. And then saying that, I'm going to rush across my slides because I only have 5 minutes. So if you have any questions, please just give me a call or send your question in the QA box. Again, when we try to compare not only yield, but also oil, we can see that the sites with higher yield are usually also the ones with the higher oil. There's kind of a relationship with that. So let's see one of the places with a higher yield. We have Minot, for example. And this is how the different varieties perform there. And basically, when we're choosing, we want to score this corner. We want to have the highest yield, and also we want to have a good percentage of oil. So we got that in this year, these varieties here, Marvelous, Cornell, Carter, and ND Gold, perform really easier. But if we go to Hettinger, that was in the lowest yield quality, we have a different behavior. Even though that ND Gold and AAC Marvelous were also in our top ranking in the best place, we have a new one that is also scoring really well, that is AAC Bright. So different sites will have different genotypes, different varieties that they are the best fit for this. Saying that, there is also another column that it's really, really important in these tables, that is the different sites, the different years. So it's not only about evaluating the yield and how this behave only in 2024, that's the last year, but also we try always to provide the year before or the 3 years before this. And I'm going to take just 1 second to see the data from Dickinson. In the table, it's included the data from 2021, 2023, and 2024 in different shades of yellow, and the 2-year average in green. So when we are comparing, we can see that if the data from the 2024, it was really similar to the 2-year average, or it was something in this year weather that was really different, and it's causing something. It helps you to evaluate if the trend that you're seeing is constant or not. And something that we were talking before, it's about the stability and yield. We can say that, see here that AAC right, it actually didn't change much across year. We have years like 2023 that the yields were amazing, but you cannot see it here. But you have years like 2021 that the yields were really challenging. But in this case, AAC right was one of the ones that dropped it the less. In the other corner, we can see other varieties like ND Gold that in the best year, it was one of the best. But in the worst year, it really dropped its yields. You can really see the difference between the years. So we can say that this is more adaptable variety, and this will be one that's more stable. Saying that, I don't have much time, but I'm just going to say that biodistricts is something important. You have to know your field, keep records. These are general. It's a general advice. And when we are talking about flax, especially, most of the varieties will have good behavior with rust and wild fusarium. It's really important also to, when we're talking about biodistricts, to have any crop actually within a good rotation. Here is just a small screenshot of which are the main diseases for flax, and which is the main control practice, and how flax wilt and flax rust, we need resistant varieties for these ones. Saying that, Please check this information. We have the variety trial tool that it will help you to get access to this information in a more friendly way. And I'm going to make a shameful advertisement and say, if you are towards the west, we are organizing a crop and pest management school that is going to be in March 5 and 6 in Bismarck. So if you're around and you're interested to learn more about different crops, just stay tuned for that. Saying that, thank you so much for your time. I'm really happy that I didn't go over time this time. I didn't have much time for questions, but just drop your questions in the QA box and I will love to answer you.